question under gas pressure measurement. So the question says in the diagram above, if the atmospheric pressure is 760 millimeters, what is the pressure in the chamber G? So this is a simple sketch of a manometer used to measure gas pressure. So on this other side, we have 10 cm. That's the height of the mercury on this other side of the manometer on the left side. While on the right side, where we have the gas chamber, the height of the liquid. Did I say mercury? Well, they didn't specify what kind of barometric or manometric liquid they are using. Hmm? So they only told us its atmospheric pressure is 760 millimeters. That's pressure height. So I can't just assume that's mercury. So on this side, the height of the liquid is 10 cm, while on this side, the height is 3 cm. On the gas chamber side, the height is 3 cm, while on the atmospheric chamber side, it is 10 cm. So we are to calculate the gas pressure on this other side. So how do we go about this? Now, the first thing you have to note is if you look at the height of this liquid, you see that the one on the atmospheric side rose higher than the one on the gas chamber side. What does that tell us? It tells us that the pressure of the pressure from the gas is higher than the pressure from the atmosphere. You know, pressure from the atmosphere acts downward, is trying to press this liquid down. But since this other gas is able to press this liquid down so that it rises above here, that means this gas here is more than that of atmospheric pressure. And then if you sketch the leveling height of this liquid, to this point, you find out that the pressure of this gas will be equivalent to the atmospheric pressure here plus the height of this liquid. That's from this new point that I've drawn to this top. If I call this place A, call this place B. So the pressure of this gas will be what? Of the pressure height of point A to B plus the pressure from the atmosphere. Do we understand? So let's get this done. So pressure from the gas, let me clean that up. So pressure from the gas, P from the gas, or we can say absolute pressure, or let me say pressure subscript G, that's pressure from the gas, will be equivalent to what? The atmospheric pressure on this other end. Atmospheric pressure, that's P atmosphere. Atmospheric pressure plus the pressure height due to the rise of this liquid. The pressure height due to this liquid. This liquid here from A to B has its own pressure that it exerting on the remaining body of the liquid. So the pressure of this gas now, since this gas is able to push this liquid to this height, it means that this gas pressure is a sum of what? The pressure height here and the atmospheric. So P atmospheric plus what? Pressure height. That's how we are going to calculate that. So now our atmospheric pressure has been given as atmospheric pressure has been given as 760 millimeters. And then our H here, which is our pressure height, what will it be? Our pressure height will be the height from here to here, which will be what? 10 cm minus 3 cm. Our pressure height H will be what? 10 cm minus what? 3 cm, which equals to 7 cm. So normally we should carry this and plug it here, add these two to give us the pressure of the gas chamber. But we don't just add that, because if you see the pressure height here, the unit of the pressure height here is different from the unit of the atmospheric pressure. So we have to make both of them to be on the same unit. In this case, I will make 7 cm to be in millimeters. So if I convert that to millimeters, first I have to convert from cm to meters. So that will be 7 times 10 raised to power minus 2 meters. Then for me to further convert it to millimeters, that will be 7 times 10 raised to power minus 2 divided by the numerical value of milli, which is 10 raised to power of minus 3. So this is the same thing as 7 times 10 raised to power minus 2 times, if you take this 10 raised to power minus 3 to the numerator, that will be 10 raised to power of positive 3. So it will cancel out this, cancel 1 0 will be left. So 7 cm will be equivalent to 70 millimeters. Are we there? So 7 cm will be equivalent to 70 millimeters. So therefore, the pressure at G's chamber, or the gas pressure, will be atmospheric pressure, which is 760 plus 70, and this will give us 830. Give us 830 millimeters. So the pressure of this gas is 830 millimeters.